Let's have a look at our ellipse. The ellipse is when the eccentricity is less than 1. So there's focus, which we label S for focus, as you remember from parabola. There's our directrix. I've labelled the intercept there Z. Now, any point on the ellipse, remember, is equal to eccentricity times distance to the directrix. So I'm just looking at the extremity here, the point A, the x-intercept if you like. So the distance from the focus to the x-intercept will equal the eccentricity. And similar to the other x-intercept over here, A dash, that S A dash will equal the eccentricity times A dash Z. Okay, going to create some equations. So SA dash plus SA, we can have a look at that and we can clearly see that distance is 2A. Because what I'm basically saying is the distance from the two x-intercepts. Got to be 2A. SA dash minus SA, using these definitions, take out a common factor of E, and I get A dash Z minus AZ. Okay. But have a look at A dash Z minus AZ. And once again, you're left with the distance between the two intercepts, which is 2A once again. So SA dash plus SA is 2A, but SA dash minus SA is 2A times the eccentricity, E. So if I add those two together, I will end up with two lots of SA dash is 2A 1 plus E, divide both sides by 2, and I have this relationship. If I was to subtract, I'll end up with SA is A1 minus E. So SA dash A1 plus E, SA is A1 minus E. Okay. The focus. We're going to find some coordinates of the focus. The distance from O to S will be the distance from O to A minus SA. But we've just said SA is A1 minus E, so it actually works out rather neat. The focus simply has the coordinates AE. The eccentricity times whatever the x-intercept is there. Now, I say plus or minus because an ellipse actually has two foci. It's a symmetric shape. So whilst there's a focus here at S, there'd be another one over here which we'd call S dash. And there'd be another directrix. Here's a directrix, but there'd be another one over here because of the symmetry of the shape. And the equation of the directrix, well, the distance from O to Z would be OA plus AZ. So AZ, if I use the definition again of the ellipse, I could rewrite as SA divided by the eccentricity. Remember, because SA is equal to the eccentricity times AZ. So subbing that in, and I get a rather neat A divided by E. So it becomes nice and neat to remember. Focus is A times the eccentricity, directrix is A divided by the eccentricity. And we're talking about lines, so that would be x equals plus or minus that. Okay. So we now know the coordinates of the focus. I want to find the equation of this ellipse. Some random point on there, just call it xy. So n, coordinates of n, we're talking horizontal line, so it's going to have the same y value. It's on the directrix, so its x value will be A divided by E. So distance to the focus, eccentricity times distance to the directrix. So distance to the focus, distance formula. Mind you, when you think about the horizontal distance, I didn't really need to use a distance formula because it's a horizontal line. I could have simply said, oh, that's AE minus whatever the x value is. But anyway, we've got the same thing there, x minus A on E all squared. Expanding out. Still looking a bit messy. We divide. Now it's in a form that we, tend to look at. And the reason we put it this way, circle, if you think about it, we go x squared plus y squared equals radius squared. So we tend to put the ellipse in the form x squared plus y squared equals something. Turns out to be 1. This denominator on the right, under the y squared, looks a bit messy. We can make that even neater as well. Because if you think about it, the other intercept, the y-intercept, which we'll call b, well, b squared over a squared 1 minus e squared, when we sub those coordinates in, we actually get that b squared is a squared 1 minus a squared. So a much neater way of writing the ellipse is a very simple one. Now, it's x squared on a squared plus y squared on b squared is equal to 1. That's the equation of your ellipse. Now, I've said this is when a is greater than b. Right? B squared will equal a squared 1 minus e squared. The focus, AE naught. Directrix is A divided by E. E is the eccentricity. Now, rather than writing it as B squared equals A squared 1 minus E squared, often it's easier to remember it this way. If you're trying to work out eccentricity, E squared is A squared minus B squared over A squared. It's just a rearrangement, if you think about this formula. Couple of terms here. Major semi-axis. So a semi-axis is like the radius of a circle. Problem is, you have all sorts of different radiuses, if you like, of an ellipse. So there's two we're concerned about, the smallest and the biggest. So the biggest we call the major semi-axis. That'll be A for our one, because we said A is bigger than B. And minor semi-axis would be the B. That'll be the smallest. Now, if B is greater than A, how does this change? Well, it now means the focus, instead of being on the x-axis, will now be on the y-axis. So, A squared will equal B squared 1 minus E squared. So the A and the B swaps around. The focus now will be 0 plus or minus BE, because we're dealing with the y values rather than the x values. The directrix will be B divided by E instead of A divided by E. Area of an ellipse, you may or may not have realised it, but you've been using it all along. It's pi AB, because that's the area of a circle. Difference in a circle is the major semi-axis is the same as the minor one. Pi times r, pi r squared. And that's where here's. Alright, let's find all those basic things then. X squared on 9, y squared on 5 is 1. We're going to sketch it to show all the important bits and pieces of this ellipse. So x squared on 9, y squared on 5, I look at that and I go, right, a squared's bigger than b squared, so it's a squared I'm interested in. We don't worry about plus or minus, we're just looking at the magnitude for this. So a is 3, so I can work out my eccentricity. A squared minus b squared over a squared gives me 4/9. How do I remember a squared minus b squared rather than b squared minus a squared? I've got to end up with a positive number. If I'd gone b squared minus a squared, I would have had 5 minus 9, which is negative 4. So I can't square something and get a negative. So it's a squared minus b squared. Eccentricity is 2/3. Foci, a times e. 2/3 times 3 is 2. Directrices, a divided by e, 9/2. Let's draw it. This is how I draw it. Now, in reality, in a test, you'd probably just get a template and go, there's my ellipse. But here's a really cool way of doing it accurately. I've drawn in what's called the auxiliary circle. It's the circle that has the same radius as the major axis. So 3. Now, this ratio of b on a becomes important. So √5 divided by 3 in this case. Now, all I really do is, on my picture, I'll get my ruler, I measure it, and then every measurement I just multiply by √5 on 3, and that's where I plot the point.
So no.
So you can do as many as you like. No. There's a vertical line, you measure it, multiply by √5 on 3, and there's my point. But the lovely thing about ellipses is they're symmetric, so I can put one below, one above. I can draw in another one, multiply by √5 on 3, there's a point. How cool is that? Look, you can see the ellipse coming along. √5 on 3. √5 on 3. And you keep going and keep going. And then there it is. Ta! They're probably not going to ask you, well, probably, definitely, they're not going to ask you to draw it using that method, but that's a really neat method. You get b over a, and there it is, nice and accurate. Whoop. Oh yes, so there's our directrices, there's our foci. Major axis is 6. Notice I said axis here, not semi-axis. So that's diameter as opposed to radius. And 2√5 for the minor one. What's this one? Well, we're going to have to complete the square to get it. All right. We prefer to complete the square on x squareds. So I've divided everything by 36, 9 fours in case you're all wondering. So I get x squared plus 2x on 4, but on the top I can complete the square and I get an extra quarter. The y's I can complete the square, I get an extra 4/9. Watch what happens on the right hand side and be amazed. That all adds up to be 1! How cool is that? So it's in the form I want. There's a bit of shifting happening. It now needs the centre is at -1, 2. B squared, you'll notice, is bigger than A squared, this one. So it's stretching vertically. So B is 3. Eccentricity turns out to be √5 on 3. So my foci, which normally I would say 0 BE, so 0 √5, but shifted to the left one up to, I get -1, 2 plus or minus √5. Directrices, y equals, normally just B divided by E, but this one's been shifted up to, and there you go. Time to have a play. Now, in one of the exercises, they ask you to